We go.
Nice, there you go, stock simulation. Started out with a block and we got this, some holes through it.
Just that easy.
It's easy as that. So start here. And the first thing you want to do is create stock. God, I've forgotten everything that I've ever done in my life.
Are you trying to start a new job?
That's the move.
Cool.
All right, so we'll start from here. The way you do it is when you start a new job. So this is, I guess actually we should do this from further back. So we have a part. The sketches are useful later. We have our part. It's got a bunch of things going on. Got holes, pockets. Yeah, it's a pretty simple part, but it's all you need. So once you have the HSMWorks add-in, make sure that's selected here. Your add-ins tab. Go to this cam tab, not SolidWorks cam, not SolidWorks cam TBM, but just cam. The other ones are SolidWorks ones and not HSMWorks, and therefore they're not as good.
Do you need the SolidWorks ones enabled?
No.
Okay.
Honestly, I'd be impressed if you were able to disable them. I've tried.
Okay.
They just keep coming back. And then over here, you can pan over to the Cam Manager tab, and we will start a new job. So based on this model, you need to create stock. And the thing that we're going to do is we're going to do a fixed size box. Usually what we do is a fixed size box because we have you're not just going to be running one part, you're going to be running lots of parts. For this though, it's pretty simple too. You can just change all of these values and then it just kind of exists like that. It's very simple. But we're going to do
It's
the
worth, I was going to say it's worth saying that the fixed size box is basically you have a piece of stock that you know the size of, and you want to put this part onto that piece of stock.
Yeah. So like usually we would have like a 12 by 24 inch piece of material, and we would offset it from one side by however much. Usually offset it by a little bit because you don't want to have it right on the edge unless you're very sure about what you're doing. Either way, we're going to do a relative size box just because it is simpler. This part is available on PDM. It's under the test folder. So we have this, we get the stock, and what we're going to do is we're going to use the stock orientation, use stock and orientation for your work coordinate system. That just means the machine kind of knows everything here. and it knows where the stock is, and that's where it makes all its calculations from. And you want to use the stock top for that. So there you go. No machines available. I think we want to use the, do I have a machine? I don't think I want to do any of that. Yeah. But you do want to have, instead of top center, you want top corner 1. And that'll just take it all from here instead of being at the center. It doesn't mean too much in this case, but it can mean more for more complicated pieces. And then you have your job. And you need to do everything that you need to do. So you need to create a new operation. In this case, we're doing a drill. So the first thing you need to do is select the tool. And hopefully you've gotten all the libraries from the guide. So what we have is, we want to do here is Herco MISC. And we want to do our 1/8 inch center drill. So that's the first thing we pretty much ever do on any of the parts is a center drill. So you select the center drill, and then you change all of the feeds and speeds based on the data that we have. This should be pretty accurate for now, but you do want to turn coolant onto flood every time. We always want to have coolant. Next up, you need to select where the center drill will actually make those initial marks for everything. So it doesn't matter what order you select these in, it will create an optimized order for you. You can choose to not have it do that and then select it in that specific order, but you just want to usually do optimized order because it's faster. So we do this here, just select everything there, move on to the next tab. And in this case, it's easier to, well, so we want our retract height, clearance height, that's fine. Then the stock top retract height, 0.2 inches is also fine. For the feed height, we want to do from stock top. And that'll also be +2 inches. And then the top would be from stock top as well. The bottom, in this case, because we're doing a center drill, you're not going all the way through. It is instead only, so we want to do from stock top again. And then we're going to plunge down, and then the center drill goes down in 50 thou, 1/8 of an inch. Robert, 50 thou?
Sure, sounds good to me.
All right, so from the stock top, you plunge the center drill tip in 50 thousandths of an inch. So you just do it. We just do it from stock top and then set a negative number there to tell you how deep it goes, just so it's all consistently from stock top. That's a lot easier to do.
What does the feed height mean?
Feed height is, well, so you can also hover over it to it'll tell you what to do. And feed height is the height that the tool rapids to before changing to the feed/plunge rate. So it's what it does is in between the different holes that it's drilling, it comes up, speeds over, and then stops, and then it'll then come down to the feed height quickly. So it goes up to a clearance height, moves over, comes down to the feed height, and then it starts moving slowly and carefully. So that's just another thing that you just be careful of, make sure that all of those are above stock top and just higher up than anything else that's being used. And then you want to do the cycle. And in this case, we usually want to do, where is it? Chip breaking or deep drilling. But in this case, because it's just a 50 thou plunge, we can just do drilling, wrap it out. And then you're good. There you go. You can check to see that it looks good in the stock simulation. So you select this, and then you click on stock simulation. You hit the play button here, and it should come down and make a little dot where all the holes are. So there you go. Looks good to me. And then what we're going to do is we're just going to create new operations. So we always want to do drilling before we do milling. And that's because it's just easier to, drilling is just really fast, pretty much. It's going to be faster than milling. And you want to make sure that you can use those center drilled holes. So if you don't, then, I mean, what's really the point? How big is this? Does anybody recall how large these holes are? They're number 10. There you go. So 0.1935 diameter, new operation. You gotta select the correct tool for this. Herco drills, freedom, because we have the metric and imperial sets. And 0.195 should be number 10 drill here. Select that. Coolant onto flood. The feeds and speeds should be correct. Before you actually run this part, you will go back through every single one of these things and check with the spreadsheets that we have in the drive just to make sure everything's correct. But this is fine for now. I get the flood going. Select the holes. I think there's something where you can select the, oh, that'll work out. It's fine. You can just select all these holes here.
There's a little thing that says select same diameter.
Aha, there you go. So you can select all the holes at once very easily like that. And then make sure to move on. We want to make sure all of the clearance heights are good. So we want to go from stock top. From stock top, those are just simple. Just want to make sure there's positive. The top here, instead of hole top, we want to do stock top. And that's important, especially here. The stock top is actually higher than the hole top for a lot of these. But the material is still up there, which is why you need to do it from stock top and not from hole top. And then the bottom, we also do stock top and depth. In this case, I think it's 0.75 inches is how thick it is. And you want to plunge the drill tip through the bottom. And we do that just to make sure that it actually goes through. You want to make your breakthrough depth 50 thou as well. And in this case, because we're doing deeper drilling, we don't want to do drilling, wrap it out. We want to do deep drilling, full retract, just make it safer. The pecking depth, for aluminum, we can make it pretty simple. So we just want to do something like 0.25 inches, a quarter inch is fine. You could probably swing a ½ inch, but it's the lower this number is, the safer it is, really. So you just go down there and then it'll come back out and it'll go in quarter inch, come out, go in ½ an inch, come out, go in 3/4 of an inch, and then come back out. And then none of the other things you really need to worry about. You set that up like that. And then you can simulate both of these at once. If you want to check them both out, you can also just do one at a time if you want, but I like to do them all just to make sure it stays right. So there's your plunge drilling right there. And it should get all of those holes. And they'll go all the way through the bottom. So there you go. And then the next part is the interesting part, and that's where we start to do 2D milling. And what we want to do here is we want to do a 2D contour, I believe. It might be a pocket.
At least the guide says pocket.
The guide says pocket. We'll do a pocket. 2D milling pocket. All right, so for this, the first thing we want to do is select a tool. And before you do that, you need to think about what you are doing in this operation. So we're removing all of the material that would normally be here. So that's a lot of material. And we want to clear it pretty quickly. So we'll use a large tool. We want to get our Herco end mills. And for this, we'll use we'll probably use a 1/2 inch flat just so we don't have to do as many tool changes. Yeah. So you want to use a 1/2 inch flat end mill, and then depending on everything. Yeah, so we could run a rougher first and then the 1/2 inch, but I think we're just going to stay with the 1/2 inch here. So we'll select the 1/2 inch end mill. And then make sure the coolant is on flood. And in this case, we want to actually make sure everything's good here. We want to do ramp lead in. Make sure it's all lead in, lead out, ramped like that. Make sure the plunge feed rate's on, not a ridiculous number. And then you start actually getting to where we want to get. So for this, we want to get the outside here and then all the way to this. So in this case, it'll take all of the material that is in between this rectangle here and this boss extrude here that we were making sure to preserve. Don't think we want to do anything with that. Clearances, again, we want to make sure that everything is from stock top. Just to be safe there. So we come up and I'm going to make sure the feed height is good. The top is from the stock top, which is correct in this case. And the bottom, in this case, we're going down a 1/4 inch for that step. So we'll be coming down to -0.25 inches. I'm going to move on to the pocket themselves. In this case, we want to do passes of about, this is actually pretty much a total pass, which is fine. Morph spiral, finishing passes, multiple taps per order. I think a 1/2 inch can do a 1/4 inch of aluminum in one pass. Did you say that's correct, Robert?
Sorry, what was the value? It's small on my screen and I can't read it.
It can do a 1/4 inch depth cut, right?
Yeah, I'd say so.
Yeah. So we'll step over about a little bit less than what the mill's diameter is, and then make sure that it can actually cut as deep as we want it to cut. Okay, so we do that. We do not want to keep tool down, just because, well, yeah, we'll keep the tool down just to, no, we won't keep the tool down. We'll be safe. We'll come up on the lift height to 0.2 inches. We want to lead in and lead out. And what this is going to be is just a little ramp here. Do we want to lead in and lead out? I don't think we want to lead ins or lead outs. I think we just want to ramp it in.
The guide says to deselect lead in and lead out.
Yeah. So once we get that, we want to do a helical lead in. Sorry, not a lead in, a ramp. And what that does is it'll just plunge it in. Instead of going straight down, it'll just spin around like a screw. And it usually has decent numbers for that, so you can just let that go. And that should be good. And then you wait for it to generate its toolpath. And then, oh, that's going to be interesting. And then we'll see if it works. So we don't really need to look at the drills. We'll just simulate that operation. I've got stock to leave there, don't I? Or is it going to do a finishing pass? So that's interesting. I'm not sure. A lot of it is fixing what happened. So in this case, we want to find out what went wrong. So you always want to uncheck stock to leave. And that's just something I forgot to do before moving on to the next pass. So stock to leave really just is not something that we ever want to work with unless you're doing a roughing pass. And we don't do that too often.
Or like things where you really need to make sure that the actual hole is precise, like maybe a bearing, but
yeah. Usually we just kind of trust that the machine works okay. It's still coming down on the top of that, which it shouldn't be. So I'm going to look through this a little bit more just to make sure that we have nothing else wrong. From stock top, come down a 1/4 inch. Selected the outside of that contour.
Try selecting just the edge instead of the face. That fixed it for me.
Very nice. Good call. All right, so that should have it work out pretty well for us. I'm not going to run the stock simulation because you can actually, just by looking at it, you can tell that it's going to be the correct way of clearing out the material there. Next step, we're going to do another pocket to get these interior pockets here. But that's the general idea of pretty much everything that we do. And we can use this 1/2 inch, we can use the same tool again, which will help us out. Use that one edge, reverse it to make sure we take the inside of that as well. Make sure all of our things are selected from stock top, not from stock bottom. And then feed height from there, top from stock top. And in this case, we've already gotten rid of a 1/4 inch of material. So we can actually move the top offset down 0.25 inches. And it's not going to let us do that, is it? Why not? It's wrong.
I think it's just because the bottom is above the top.
That checks out. So you want to do the bottom first and then the top. So we want to make sure that the bottom here is down to where we want it to be. And that is, if I recall correctly, 1/2 inch from the top. So it should be negative 0.5 inches. And then the stock top fixes itself and we'll go right there. Want to move on to all of that. Make sure to uncheck stock to leave. This stuff should be good. And then moving on to this part, we do not want to keep the tool down because we have 2 separate pockets. We'll allow rapid retract, no lead-ins or lead-outs. Keep the helical entry ramp on and generate that toolpath. And you should, just by looking at it, see that it should be good there. We'll run both of those just to make sure that it actually looks good. This is a kind of, you can speed it up a little bit, but really only go by 1 tab, because if I move to the next one, I think the entire thing will be done in about 2 seconds.
Yeah, it's like a logarithmic scale on the simulation for some reason.
So there you go. Got the pockets there. And then do we use a contour on this next one? Wait, I can just got it. Now it's all pockets. Good, 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 good. So then you do the same thing again 2 more times down here. And interesting. So we'll keep using the same tool. Make sure the coolant is on flood every time. And we will select this sketch here. Or will we? And that will get us for that one. Make sure your tools are all from the correct place again. Let's change the bottom first this time. In this case, we're going down also 1/2 inch. That's not 1/2 inch. I think that's going to go down 3/8. So we'll go down 3/8 of an inch. Yeah, it's 3/8 there. And then the stock top will be negative 0.25 inches because we've already cut that. And the thing to maybe worry about a little bit here is if you ever rearrange the tools that you have to make sure that the stock top is the top of this operation is not embedded in the stock already, or else it will think it can just plunge the end mill directly into it, and then things will break and you will be sad. So make sure to uncheck stock to leave, and then uncheck lead-ins and lead-outs. Make sure the helix is good. We will not keep the tool down, and that will give us another operation done. Looks good to me. And we'll do it one more time. Down here, it'll just be the exact same thing. Make sure it's correct. Select the edges here. that should be good. Make sure it's cutting on the inside of that. You get your clearance heights from stock top, from stock top, from stock top, from stock top. You change the bottom down to where it needs to be. That one's down -0.5 inch. And this one is, we can lower down even further to -0.375 inches because of the previous operation. Come down here, uncheck stock to leave, move over to the next tab, uncheck lead in, uncheck lead out. And that should be a toolpath for that operation. Unless, of course, it gives us an error. Why is it giving me an error? Something's wrong. It doesn't like this. Did I not select all the sketch edges? Aha. No, that wasn't it. There's something wrong with this pocket. And I don't know what it is. Sometimes things just go wrong. Stock top, stock bottom, good. Sketched on that. All stock top from stock top. Not doing the passes are fine. Not keeping the tool down. That was it. It was just not keeping the tool down. Interesting. Okay, so then you can check that everything works. You can select all of these. You can look at these tool paths if you want. Kind of hard to tell when they're all on top of each other. Just do a stock simulation. Can make sure that all of the operations are working out. See, I moved it one tick and it was done. There you go. So as you can see, everything's good except for I did not get this deep enough. And that's just remembering the numbers. So it looks like I need to come down another 1/8 of an inch on that. So you just come back in here. Go to the heights. And then instead of 0.5 inches, you're going to do 0.625. And you can actually see where it is. I just didn't look too closely. But this blue plane here should be right at where you want the cutoff to be. And there you go. And that's actually correct. You can see that all of the cuts are where you want them to be. The holes are all through. And there is nothing glaringly missing or anything like that. So that's the easy part. Actually doing it is the hard part. But what comes next is you need to post the process. So you go to post process, you select the milling, and we have the Herco here. If you did all of the tool paths, tool libraries, and post libraries into the correct places, that should be there. You'll have the Herco selected, and then you can post it. Obviously, before you post it, you'll talk to one of the more experienced people on the team, and probably also Bachman, who will tell you everything you did wrong, and then help you fix it, and then let you actually do it. In this case, I guess this needs to be a number, but that's the idea. Any questions? Also, please feel free to reach out with questions to me or to anyone else on the call right now. So, yeah, there you go.
Jackson, have you looked at the numbers in the guide? I don't think it's a huge difference that some of yours were different than what the guide says.
The feeds and speeds, or the drills and heights and stuff.
Some of it was heights, not all of them. Some of them just did a few different things. I don't think anything would break anything, but
Yeah,
I'd say look at it and make sure.
Yeah, look at the guide. Use the numbers in the guide. If anything I said conflicts with something in the guide, go for the guide. And then we'll check everything afterwards too as well. So there you go.
Yeah, and also there are definitely different places you can look online, like typical depth of cut for this tool, and you'll find something, or good pecking distance for this type of drill, and you'll get something. And those are certainly useful as well if you don't have those in memory.
Yeah, we do also, we have in the guide, there are in the machining folder, in the resources folder in the CWRUbotix Google Drive, there are a lot of very good resources for all sorts of speeds and feeds, and also just general good information if you want to memorize, several thousand different numbers. But that all is definitely very useful information that you can just, that is very helpful to know where it is at least. So there you go.
So how does you talked about it, how does the 2D contour work as opposed to 2D pocket?
Right. That is a good question. For a 2D contour, we do, God, I don't even remember. I haven't done this stuff in a while. I think for a contour, you would usually select a face and then other things. No stack to leave. Don't want lead ins or lead outs. Don't want to keep the tool down. So a contour can be, I guess, useful if you're just trying to get rid of material around something. I don't know. What am I doing? Right, I still have the speed way up. I think you can change some settings in there. Honestly, for everything that we do, we can just use a pocket pretty much. But for the more complicated things, it's sometimes useful to be able to choose something else. Yeah, so a contour here would not cover everything. So if you have like two different things, instead of doing instead of clearing out all the material in between the sketches, it will just follow along that sketch line. which can be useful. But
Say if you want to cut out multiple parts on a single plate, you can do a
Yeah.
contour around each part and then you're done.
yeah, so there are definitely uses for contours. Yeah. There's a lot of different operations out there. Mostly, we will pretty much never do any 3D milling. There are some things that can be done if we really need them to be done. But we'll pretty much just do 2D milling for any milling that we'll be doing. Sometimes we'll be boring. Yeah. Oh, and threading. We can do threads as well sometimes, but usually we'll just do that by hand.
Isn't that just a recipe for breaking taps?
Yeah. Yeah.
So can you also like import multiple parts to work on at once for like a single sheet?
Yeah, so in the guide, it actually tells you kind of what to do there. So in that case, if you want multiple parts that you're trying to make out of one sheet, what you do is you put them all in assembly, arrange them where they need to be with some space in between them, and then you can save an assembly as a part. And that's what you'll do. So you'll save that assembly as a part, and then that part, you just do it kind of like this, and you can cut out the pieces using the contour tool. It's pretty useful.
Okay.
Yeah. So there you go. Yeah. Before we do anything actually on the machine, we do run literally everything by Bachman. He'll go through all of the speeds and feeds, the heights, the depths, all of where the pockets are, everything like that. And then he'll tell you where you went wrong when you do something wrong, not if, when. So there's always something wrong. And then you'll be able to get through that eventually. Yeah. HSMWorks. Mastercam is very similar. I think there's like some weird way to get access to it through Citrix, but I don't think we're doing anything on the Haas, so HSMWorks is good. Yeah.
Cool. So thanks, Jackson. I'm gonna stop the recording.